video, we're looking at electromagnetic waves still, but this time we're going to look at a specific part of that, and that is visible light. So by the end of this video, you should be able to explain how wavelength and frequency affects the colors that humans see, as well as describing some of the mediums as well, how light behaves with some mediums. All right, so, we got to talk about the energy first, right? Waves carry energy, and so when we talk about the energy that comes from the sun, we're talking about radiant energy, or you may hear it also referred to as light energy. And that's just energy that's given off by the sun, and it travels through electromagnetic waves, which are what type of waves? Transverse waves. And again, another name for it is light energy. So some of the sources of light. The most common and the one that is pretty much the sole provider here on Earth naturally is the sun. And basically how the sun produces light, it's because it's so hot. The sun is so hot that it gives off all of the visible light waves possible, which we'll talk about in just a second. It's called incandescence. When something gets so hot that it glows or bursts into flames, it's incandescence. We see this sometimes in an incandescent bulb. All right, some living things also are producers of light. So if you look really deep in the ocean where there's not sunlight penetrating the water, there are these creatures. It's called bioluminescence, when a living organism through a chemical reaction actually produce light, and it's so cool. An example of this would be jellyfish. Another example would be the anglerfish, the one in Finding Nemo that has the little light out here, as well as fireflies. Obviously, there's also artificial light. Some bulbs that we'll talk about a little bit in class are incandescent bulbs. These are the older bulbs that actually run the electrical current through the little wire right here. The wire gets so hot that it glows and creates light. There's halogen bulbs, and then the most common that we probably use now are fluorescent bulbs. These are what's in my classroom. So these are all the sources of light. There are obviously a couple more as well. Okay, so in order for us to understand where visible light comes from, we have to look at the electromagnetic spectrum. And this is the spectrum of all of those electromagnetic waves, all the types that you can have. And they all vary based off their wavelength, which then in turn affects their frequency. And so obviously the smallest are gamma rays, whereas the longest wavelength waves are going to be AM radio waves. And so visible light kind of nestles right there in between ultraviolet and infrared rays. Infrared, sometimes known as heat, okay, infrared cameras, right, they can see the heat coming out. So visible light nestles right in between there. And each one of these colors in the visible light spectrum also have varying amounts of energy, which means they have a varying amount of the varying wavelength, right? Because the wavelength is going to determine how much energy that wave carries. And so visible light is the wave energy that we can see. So it's the one little tiny part of that spectrum that our eyes can register as colors. And it's made of many colors. It's made of red, orange, yellow, green, blue, indigo, and violet. And these waves travel in a straight line. All right, so how do you remember all that? Remember it by Roy G. Biv. Red, orange, yellow, green, blue, indigo, violet. Roy G. Biv. And each one has its own unique wavelength. Okay, I want to make sure you know how we kind of remember this. Roy G. Biv is the exact order that they also come in as well. Okay, red have the longest wavelengths, whereas violet has the shortest. Okay, so we start with the longest with red, and they kind of decrease wavelength as they go. So we can use a prism to tell visible light. What happens is you can take this glass prism and you shoot in white light through it, and then out of the prism is going to come all of the different colors that we just talked about. Roy G. Biv, red, orange, yellow, green, blue, indigo, and violet. In nature, water acts as a wonderful prism as well. So when we see light, what does this look like? When you look at something, you're actually looking at the color that is reflecting off of that object. So white light comes in, and the object might absorb some of those different colors and then whatever is bounced off is what you're going to see. So, for example, this green leaf is green, okay? So, what colors does it absorb? It absorbs all but green. It bounces green off, and you see that in your eye. For we looking at black and a white surface, black absorbs all colors, whereas white reflects all colors. So when you're actually looking at a white surface, you're seeing all of the visible colors of light. When you're looking at a black, you're seeing an object that has absorbed all of those colors. That's why we use black in our solar ovens, right? It's going to absorb all of that energy. You wanted that energy absorbed so that you could have the heat. We didn't use white. This is the same reason you wear white on a hot summer day, is because it reflects that light, so you're not absorbing that energy, making you warmer. So light waves behave in a certain manner. We've talked about absorption and reflection, but they do a couple others as well. And so when light is absorbed, it's just kind of like a sponge soaking up water. It enters a substance and it changes into another form of energy. So that object then has all of that energy that came from that light wave. As we talked about, darker colors are going to absorb more light. Those are, if you want to stay warm, wear dark colors. If you want to stay cool, wear lighter colors. Objects also can reflect light, and that's just when light's bounced off, right? So you look in a mirror and you're seeing light reflected, which allows you to see yourself. Okay, it just bounces off an object. Now, here's a new one that you may or may not have heard of, and that's refraction. So if light refracts, it's when the light actually bends between two mediums. So if it crosses two mediums and it bends, that's refraction. And so we see this most of the time when you stick a straw in a cup of water or a spoon in a cup of water, as we have here, and it looks like the spoon's bent, or it looks like it doesn't quite match up. And that happens because you're looking at it between two mediums, and we call that refraction. Here the medium would have been air and water. The last one we're going to look at is scattering. And so when light waves redirect in many different directions, so when they start bouncing everywhere and then they don't travel in a straight line, when they come in contact with a medium, then you have scattering. So keep in mind, the air is a medium. Why? Because it has mass. And so that affects light waves. And we commonly see this when we go outside on a nice day, well, any day. We look up, and what color is the sky? The sky is blue. And that happens because blue is scattered in the sky. So the molecules in the air actually cause that light to be scattered, and it causes the blue light specifically to be scattered. Blue has smaller waves. And so those kind of hit those molecules and scatter throughout in all the directions, causing the sky to be blue. So when you look up at the sky, you're actually seeing the reflection of blue light scattered across the sky. It's a little bit more complex than that, but that's the basics. So what happens when light interacts with mediums? We can use 3 adjectives to describe how an object interacts with light. Being opaque, being translucent, or being transparent. So to be opaque is when an object does not allow light waves to pass through it. So you cannot see through an opaque object. For example, my hand is opaque. I cannot see through it. Sometimes an object might let a few light waves pass through, and we call that translucent. So if some gets through, but not a lot, it's almost see-through, but not fully, that would be translucent. So when we see in this picture, we can kind of see her behind this wall, but not fully. Okay? The last one we're going to talk about is transparent. And when something is transparent, it is going to allow all the light waves to pass through it. You can see through transparent objects. So sometimes somebody might tell you, you need to be transparent, right? It means that you need to be open and you need to allow somebody to see, right? Because that's what transparent is. You can see through it. It allows all the light to move through that object. like this glass of water or a window or thinking of something else that's transparent. Any piece of glass really is going to be transparent, hopefully, if it's not too dirty. All right, so can you tell me what visible light is? Where do we find it on the electromagnetic spectrum? What happens when we look at an object? What color do we see? And then how light waves behave and how we can describe objects in reference to how they allow light to pass through them. All right, that's visible light for you.